Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Today we are going to discuss about the Pythagoras theorem and basic proportionality theorem, next Savoy's theorem also, and Apollonius theorem. So let us discuss about this. That means we are just taking the statements from these theorems. First, Pythagoras theorem, you already know about it. So in a right angle triangle, square of hypotenuse is equals to sum of the squares of other two sides. Am I right? Yeah, synopsis for in plane geometry. First, Pythagoras theorem. The statement I am just reading. In a right angle triangle, square of hypotenuse. What is the hypotenuse? Hypotenuse is nothing but the longest side or largest side of a right angle triangle. And here you should remember that the largest side is always opposite to the largest angle. Same way, the smallest side is always opposite to the smallest angle. Okay, now if you take the right angle at B, AB and BC both are connected to B. That means AB side and BC side are adjacent to B, but AC is opposite to B. So that's why we can take the opposite side of largest angle is largest, nothing but hypotenuse. Okay, and remaining two is regular sides. Okay, now whenever 2 represents the length of a triangle, we are using the small letters to measure the length of a triangle. For example, BC is a side which is opposite to vertex A, so we can consider the length of BC is small a. Same way, AB is opposite to vertex C, we can take length of opposite side. That means length of AB is small c. Now can you just say the length of AC? Very good, B. So according to the Pythagoras theorem, hypotenuse square, that means in a right angle triangle, square of hypotenuse is equals to sum of the squares of remaining two sides. That means square of hypotenuse B square equals to sum of the squares of remaining two sides, A square plus C square. Okay, na? Right. Now, when you got this statement, I am not going to prove any statements here. Here we should discuss some of the important properties near the right angle triangle. So let us verify that. For example, in a right angle triangle, if you construct one of the right angle or one of the perpendicular altitude from the right angle, like ABC is a right angle triangle and angle B is 90 degrees. Now from vertex B to AC, I am just drawing a perpendicular line segment. BD is a perpendicular line segment. So this one we have already discussed in our previous classes. That means BD square equals to AB square plus BC square. BD square equals to AD into DC. That is the condition we have discussed, right? From this we have discussed one condition, that is BD square. Here BD is nothing but altitude which is drawn from the vertex B to AC. That is equals to AD into DC. Yesterday, and that means in a previous class, we have already discussed how it came. Okay, na? This is one of the important property we are going to use in our problems which is related to right angle triangle. Okay. Now second one, Pythagoras theorem. This one you know, AC square is equals to AB square plus BC square. Nothing but square of hypotenuse equals to sum of the squares of remaining two sides. Okay. Now coming to the third statement. Yeah, let us consider the length of BD is P. Length of BD is P and its length of BC is A, length of AB is C and length of AC is B. So from this we should discuss one more, that is P into B. P into B equals to AC, so that means C square plus A square, sorry, A into C. Here one more condition we should discuss. The condition is P into B. That means the length of BD into length of AC is equals to length of AB into length of BC. That means A into C. This is also one of the important property we should use. And next property, 1 by P square. Next property is 1 by P square equals to 1 by A square plus 1 by C square. So from a single right angle triangle we should remember all these properties. Okay na? So first one we know already by using the Pythagoras theorem, and second one, when you draw one more altitude from the vertex B to AC side, that altitude length BD equals to AD into DC. That is the first statement. Second one, BD equals to AB into AC. Yeah, this one, P into B. P into B equals to A into C. And third one, 1 by P square is equals to 1 by A square plus 1 by B square. These four properties we should remember. Okay. Now let us go to the Apollonius theorem. So the Apollonius theorem is discussed about Apollonius theorem. So that means if you take a triangle ABC, we are not taking a right angle triangle here. I am just taking a ABC is a triangle and AD is a median. AD is a median. Median means what? That divides the opposite side into two equal parts. So median is nothing but the line segment which is drawn from vertex to opposite midpoint. That means here BD length, DC length equal. Okay na? Now from the Apollonius theorem we should discuss that sum of the squares of any two sides of the triangle. That means sum of the squares of any two sides of the triangle. That means AB square plus AC square is equals to 2 times of half of the third side. 2 times of half of the third side. What is the third side? BC. Half of the third side means BD. So 2 times of the square of half of the third side and 2 times of median square. So this is the Apollonius theorem. If you take a triangle like this, AD is a median which is drawn from A to D. From this statement, from this construction, we have to derive a statement like AB square plus AC square is equals to 2 times of BD square plus 2 times of AD square. So that is only given clearly. Yeah, just take that. So the sum of the squares of two sides of a triangle is equals to twice the half of the square of third side and twice the square of the median. Okay na? The median should be drawn to bisect the third side. Okay. Now from this statement here AD is a median. From this statement AD is a median. To identify the length of median, we are using the Apollonius theorem. just to find the length of the median by using the triangle three sides, length of the three sides of a triangle. Okay, now we know already this one is A and it is B and this side is C. So from this, let us try to convert into the terms. AB square is nothing but C square, AC square means B square, equals to 2 into BD. BD is nothing but half of BC. That means I can take that BD as A by 2. Okay, na? Whole square plus 2 times of AD square. AD is nothing but the length of median. Now from this, C square plus B square equals to 2 into A square by 4. 2 square value 4. 2 table in denominator 2 times comes plus 2 times of AD square. We need to find only the length of AD square. So let us transpose A square by 2 towards the left hand side. That will be C square plus B square minus A square by 2. Okay, na? So try to do LCM. It will be 2C square plus 2B square minus A square divided by 2 equals to 2 times of AD square. Okay, na? So that implies AD square equals to, again 2 is multiplying, when you transpose it is going to divide, that is equals to 2 times of C square plus 2 times of B square minus A square by 4. Because it is already having 2, this 2 also when you transpose divided by 2, so 2 into 2 becomes 4. But we want only AD value. So what is AD value? AD equals to, when you square, you transpose right hand side, it will be square root. Square root of 2C square plus 2B square minus A square divided by 4. So 4, root over 4 is nothing but 2. That means denominator 2 will be the square root only for remaining terms. 2C square plus 2B square minus A square. Okay, na? That is equals to, we can write 1 by 2 into root over 2C square plus 2B square minus A square. This is the length of the median which is drawn from vertex A. Okay, na? Let us check. If you have drawn the median from vertex B, how can you write? From vertex B, we can write that from vertex B by using the same concept. From vertex B, median, let us take this one as BE. Median BE is equals to 1 by 2 into square root of 2A square plus 2C square minus B square. That's it. Opposite to vertex B, so minus B square will come. Opposite to vertex A, minus A square will come. So opposite to vertex C, minus C square will come. So like that, according to our convenience, we can write the formula once you remember this formula. Or else at least you should remember this statement from Apollonius theorem. Okay, na? Let us come back again. From the right angle triangle by using the Pythagoras theorem, first one, hypotenuse square is equal to side square plus side square, and the second property, BD equals to, or BD square equals to AD into DC. BD square equals to AD into DC, and last one, 1 by P square is equal to 1 by A square plus 1 by B square. P is the length of the perpendicular, A and C are the remaining two sides except the hypotenuse. And also we can take that P into B equals to A into C. These four conditions, here Apollonius theorem, nothing but length of the median formula, that is equals to half root over 2b square plus 2c square minus a square. Okay, na? Let us go to the next concept. And also here one more statement, one note point is given, that is, if ABCD is a parallelogram, if ABCD is a parallelogram, you should remember the statement like, if ABCD is a parallelogram, we can write parallelogram like this also. ABCD is a parallelogram, then here the condition must be, remember that AB square plus BC square plus CD square plus DA square. Nothing but AB, BC, CD, DA all are length of the sides of a parallelogram. So simply sum of the squares of the sides of a parallelogram is equals to AC square plus AD square, BD square. AC square plus BD square. When you take that parallelogram like this, ABCD, AB square plus BC square plus CD square plus DA square equals to AC square plus BD square. This is also very, very important notation. Note point. Okay, na? So let us check that one more note point is given, that is, yeah, when you take a triangle and medians, when you take a triangle and medians, I am taking the triangle ABC like this. ABC are the sides, vertices of a triangle. AB, BC, C are the sides, and AD, yeah, DEF are midpoints of the sides of BC, CA and AD respectively. Then the condition is 3 times of AB square plus BC square plus CA square or AC square. That means sum of the squares of a triangle with 3 times is equals to 4 times of sum of the squares of medians. Nothing but AD square plus BE square plus CF square. Okay, na? So 3 times of the sides of a squares of the triangle is equals to 4 times of the sum of the squares of medians. Okay, na? Yeah, and that too, when you take a triangle or number of triangles having a same base and having a same vertices or same vertex, and their sides are in the same ratio according to the, yeah, let us see. For example, I am taking a common base like x and y, and here a common vertex is P. Now I am taking lot of points on a line segment. I am just trying to draw the lines from P to all the points. Now see here, I am taking the points as A, B, C, D, E. Okay, na? So we can see so many triangles here. Okay, how many triangles are there? Here 1, 2, 3, 4, 5, 6, like that. So many triangles will be there. Now all are having the same base. And the same vertex. So we can take this. The sides are in the same ratio. That means, let me take, yeah, the ratio of the areas of triangle. For example, I am taking the triangle PAB triangle, this triangle, PAB triangle, and triangle PBC. Area of these two triangles ratio is equals to AB is to BC. Okay, no? Right. So that is also the important point. And Savas theorem. Let us take about the Savas theorem. Okay, so before going to discuss about the Savas theorem, let us take some concept based questions. Then we'll go through the Savas theorem. Okay, na? Yeah, concept based questions. Right. Let us discuss about the first question. In a triangle ABC, angle B is equal to 90 degrees. In triangle ABC, angle B equals to 90 degrees. Then from this right angle triangle, which theorem you have to remember? That is Pythagoras theorem. According to the Pythagoras theorem, BC is nothing but A, AC is equals to B, and AB is equals to C. So from this Pythagoras theorem, square of hypotenuse is equals to side square plus side square. So this you should remember. So while you are observing the options also, the second option will be correct because right angle at B. So larger side also B square. If the right angle is placed at the vertex A, then A square is equals to B square plus C square. And this question can be asked in so many different ways, like in a right angle triangle. The question is forming like in a right angle triangle, C square equals to A square plus B square. Then the angle C equals to how much, or at which vertex or at which angle makes 90 degrees angle. Angle C equals to 90 degrees. Okay, na? Yeah. So according to the first question, option is B square is equal to C square plus A square. So let us move on to the second question. In triangle ABC, A square is equal to B square plus C square. Same condition I told you, no? So A square is equals to B square plus C square. Then when the right angle is located at vertex A. Angle A is equals to 90 degrees. Angle A equals to 90 degrees. Okay, na? Now the third one, if B square is greater than A square plus C square, B square is greater than A square plus C square. We know that B square is equals to A square plus C square, that is right angle triangle. B square is equals to A square plus C square, that is right angle triangle. But here B square is more than A square plus C square, that will be obtuse angle triangle, because it is somewhat more than the right angle here. So B square is equals to A square plus C square. So A square plus C square. So it will be obtuse angle triangle. Okay, na? Right. Now the question number 4, in triangle ABC, angle B is obtuse angle triangle and AD is perpendicular to BC. What is the question? This is question number 3. So question number 4, in obtuse angle triangle, B is an obtuse angle. Yeah, B is an obtuse angle. AD is perpendicular to BC. AD, that means AD is nothing but altitude. Altitude will be outside of the triangle. Okay, na? AD is perpendicular to BC. Then here we should discuss the condition like AB square plus BC square equals to AD square. Yeah, 2 times of BC into BD. Yeah. For example, if you take the letter here D, so we need to prove that. Let us try to prove this theorem. So let me take the diagram properly. The fourth question is given that angle B is obtuse angle. Angle B is obtuse angle, and we are going to draw altitude AD to BC. Altitude AD to BC. Okay, na? AD to BC. Then what we can prove? Okay, let us see this. I am taking a triangle ADC. ADC is a right angle triangle. Am I right? ADC is a right angle triangle. From this we can learn that hypotenuse square, AC square is equals to AD square plus DC square. AD square plus DC square. And again we can write DC as DB plus BC. Can we write DC? The total length equals to DB plus BC. Yeah, DB plus BC whole square. Just apply A plus B whole square format. That is equals to AD square plus A plus B whole square format. A square plus B square plus 2AB. That is nothing but DB square plus BC square plus 2 times of BD into BC. 2 times of BD into BC. Yeah, before going to do that one, just check the options. AC square is equal to AB square plus BC square, 2BC BD. Okay, right? So AC square equals to AD square plus DB square plus BC square, 2 times of 2 times of BD into BC. Okay, now I am taking this triangle. This is also right angle triangle ADB. Okay, na? So from this right angle triangle, so in triangle ADB, hypotenuse AB square will be hypotenuse. AB square equals to AD square plus DB square. AD square plus DB square by using the Pythagoras theorem. That means whenever you see AD square plus DB square in this diagram, you can write AB square. See, AD square plus DB square is equals to AB square, on left hand side AC square. So AB square plus BC square plus 2 times of BD into BC. This is actually what we have to prove for obtuse angle triangle. So option is C, I think so. Yeah, option 3. Okay, na? First I have taken that largest right angle triangle. There are 2 different type of right angle triangles which are having a same right angle at D. So ADC right angle triangle, I just apply the Pythagoras theorem. AC square is equals to AD square plus DC square. Okay, again DC we can write DB plus BC. So A plus B whole square format you apply A square plus B square plus 2BC. And second right angle triangle we can take AB square is equal to AD square plus DC square DB square. So in the place of AD square plus DB square we can write AB square. So AC square is equal to AB square plus BC square plus 2 times of BD into BC. Okay, na? Right. So question number 4 also completed. Let us go to the problem number 5. Yeah. Problem number 5 is given in triangle ABC, AD is a median. In triangle ABC, AD is a median. Okay, let us take AD is a median. Right. And then we need to prove that AD is median. So according to the Apollonius theorem, median means what? BD and DC are same. What is Apollonius theorem? In a triangle, sum of the squares of any 2 sides. Sum of the squares of any 2 sides is nothing but AB square plus AC square is equals to 2 times of BD square plus 2 times of AD square. This is the statement we should remember from Apollonius theorem. And here we discuss the length of median also. What is the length of median AD? Nothing but AD is equals to half into square root of 2B square plus 2C square minus A square. This is the length of median. From this diagram we have drawn from the vertex A. If it is drawn from the vertex B, that is equals to half into square root of 2A square plus 2C square minus B square. Okay, so let us go to the problem number 6. In triangle ABC, DEF are taken as on the BCCA AB respectively. So that this is the Savas theorem. So that the lines AD, BE, CF are concurrent. So here not discussing about any medians or any midpoints. That means if you take any triangle ABC like this, DEF are the points on DEF are the points on BC, CA and AB, and when you join them, they must be the concurrent. Concurrent means more than two lines having a same common point. Only two lines having a same common point, intersecting lines. More than two lines having a same common point, concurrent lines. So if they are congruent, then the Savas theorem is telling that, according to the Savas theorem, the statement is BD by DC into CE by EA into AF by FB, that is equals to 1. This is Savas theorem. Okay, na? Yeah, BD by DC into CE by EA into AF by FB is equal to 1. So from that, the option will be last fourth one. Okay, na? So until here we completed the concept based questions. Okay, na? So we discussed about the Pythagoras theorem, obtuse angle triangle. When you use that obtuse angle triangle, the altitude AD square, how we are doing that one, AC square equals to AB square plus BC square plus 2 times of BD into DC. Okay, na? From obtuse angle triangle, when you draw altitude from the vertex A and obtuse angle at B. Okay, so let us continue the level 1, nothing but exercise 1 problems. Yeah, see the first problem. If transversal cuts the sides BC, CA, AB suddenly, suitably extended triangle ABC at point DEF. So previously, while we discussing about that Savas theorem, we just taken that CF, AD and BE are just congruent lines. We did not discuss about the medians or not, but here same diagram, if they are transversal, according to the Savas theorem, if we are considering these are transversals, then the statement will be BD by DC into CE by EA, BD by DC into EC by EA into AF by FC, AF by FB. Okay, na? Same statement, that is equals to minus 1. CE by EA, AF by FB equals to minus 1 when the concurrent lines are becomes the transversals. Okay, na? So that is also you should remember. Let us go to the question number. So from this we can write BD by DC into CE by EA into AF by FB is equals to minus 1, where AD and BE and CF are the transversals. Okay, the second question, in triangle ABC is an isosceles triangle at angle C is 90 degrees. ABC is isosceles triangle, at the same time angle C is equals to 90 degrees, that means these two sides are equal. Okay, that means AB is equals to BC because it is only the right angle isosceles triangle. Then AB square equals to, what is AB square? Use the Pythagoras theorem first. Hypotenuse square, AB square equals to AC square plus BC square. Okay, na? Yeah. And we know that AC length and BC length both are same. from this AC square, in the place of BC square also we can write AC square because both of them are equal sides. So AB square is equals to 2 times of AC square we can write, or AB square is equals to 2 times of BC square also we can write. Anything is same or anything is correct here from these two. Okay, so according to your option which is given that, yeah, 2 times of BC square must be AC square, BC square 3 times. Last option, 2 times of BC square or 2 times of AC square we can take. Okay, question number 3. So in a triangle ABC, if the sides are 11 and 5 centimeters and 8 centimeters, then the triangle ABC is an dash angled triangle. Which angle triangle? Can it be the obtuse angle triangle or not? Let us discuss here. We know according to the Pythagoras theorem, if it is having B is 90 degrees angle, this is small b, so small a, small c, we can take that B square is equals to A square plus C square. Okay, na? And also discussed about the obtuse angle triangle, B square is greater than A square plus C square. We can consider that triangle is an obtuse angle triangle. But here the measurements also given, the measurements are 11, 5, 8. According to the third problem, the measurements are 11, 5 and 8. 11 centimeters, 5 centimeters, 8 centimeters. According to the first one, 11 square value and 5 square plus 8 square value also will find. 5 square value is 25 and 8 square value is 64. When you add this one, 89. So 11 square is 121. So obviously 11 square is equals to remaining square of the remaining two sides. So it will be definitely an obtuse angle triangle. They are the measurement of obtuse angled triangle. Okay, please check. Now question number 4, that is given that, so in triangle ABC, B is an acute angle triangle, AD is perpendicular to BC. Okay, so this problem we are going to continue in the next class. Thank you one and all. Have a nice day. Bye bye.